Let's do example number 6. It says the half-life of radium-226 is 1620 years. So radium-226 is an element, it's a radioactive element. Its half-life is 1620 means it keeps on decomposing, and in 1620 years it becomes half of what it was before. So in a sample which is originally 1 gram of radium-226, the amount A of T in grams is given by this function. So we have this function A of T is equal to half raised to power T by 1620 in T number of years. So T here is number of years after the start of the experiment. How much radium will be present after 1620 years? So part A is asking you if T is equal to 1620 years, you have to find the amount of at that time for the radium. So A at 1620, all you have to really do is in the given function in place of T, you have to write 1620. So you can see here this can cancel. So that is just half raised to power 1, it is just half. So we have half a gram of radium 226 would be left after 1620 years. Part B asks how much of the amount will be left after 3240 years. So in the given function, you need to plug T to be 3240 divided by 1620. So I think 1620 times 2 is that. So that gives you half square. That will be 1/4 of a gram. Part C here asking about 4860 years. Amount after these many years, it will be half raised to the power 4860 divided by 1620. I think this can cut at 4. So we have half raised to power 4, which would be 1 by 16th of a gram would be left after 4860 years. Let's look at example 7. A 2010 estimate of population of Mexico is 111 million people with projected growth rate of 0.994% per year. At this rate, if it keeps on growing, the population in millions can be approximated by this function, where t is the time in years since 2010. Evaluate P of 4 and interpret its meaning in context of the problem. So let's evaluate it. P of 4 meaning t is given to be 4. So that would be in the function raised to power 4. I can use calculator to do that. We have 115.48 million. So what does it mean in the context of the problem? So what does it tell you? This is the population in millions in T years since 2010. So here T is given to be 4. That means year in year 2014 population would be in Mexico would be 115.5 million approximately. That would be the meaning of the application. Similarly, let's evaluate P at 75. So here you think T is given to be 75. That means 75 years since 2010. That means in year 2085 population would be equal to P of 75, which would be 111 times 1.00914 raised to the power 75. We can use our calculator to calculate that. That is 233 million approximately. So the population in 2085 would be 233 million. So it's very important to understand the context in the problem. Otherwise, there's no use of the math, right? If you don't understand what that number actually means. So that was section 4.2. Let's work on some concept connections. The function defined by y is equal to x cubed is or is not an exponential function. It's not, because the base has to be a constant. Whereas the function defined by y is equal to 3 raised to power x is an exponential function because the base is 3, which is non-zero and which is more than 0 and not equal to 1. Graph of the function f of x is equal to 5 by 3 raised to power x is increasing or decreasing. So you need to check the base, which is 5 by 3, which is more than 1. That means the function has to be increasing function. The graph of the function 3 by 5 raised to power x is decreasing or increasing. Again, you have to check the base, which is 3 by 5. This is less than 1. That means the function has to be decreasing function. Domain of an exponential function. So b raised to power x, right? Domain is all real numbers, negative infinity to infinity. On the other hand, the range of an exponential function, we saw the graph was always above x-axis. That means 0 to infinity. And make sure the 0 side is round bracket. All exponential function b raised to power x always pass through the point 0, 1. The horizontal asymptote of an exponential function is the line x-axis. So the equation is y is equal to 0, or we can say x